Hello and welcome to today's talk about the stomach. Now, with any viscera, I like to talk about the three main things that are key to anatomy, so structure, position and function. The next thing that I'd like to talk about is also the neurovascular supply and the lymphatics. So, we'll start off with the structure. With the structure, there's four things you mainly need to know. So you need to know general structure like size and shape, surfaces and features, parts, and internal features. Now, generally, it's the stomach is a sac-like organ, and it's shaped in the form of an inverse J. It has an anterior and posterior surface, and these are separated by upper and lower borders. Now, the upper border is known as the lesser curvature, and the lower border of the stomach is known as the greater curvature. Now, the lesser curvature has a little notch in it called the angular incisor, and it's located around here. Alright, now the parts of the stomach, around the gastroesophageal junction you've got the cardia of the stomach. Above the level of the entry of the esophagus you've got the fundus of the stomach. Between the esophagus and angular incisor you've got the body of the stomach. And between the angular incisor and the end of the and the beginning of the duodenum you have the pylorus. The marking between the pylorus and the duodenum is by the small vein here, which is known as the prepyloric vein. The pylorus is divided into proximal and distal parts. The proximal part is known as the antrum, and the distal part is known as the canal, the pyloric canal. Alright, now we're now ready to talk about the internal features. Well, the internal features are basically its mucosa is thrown into prominent gastric folds or gastric rugae, and that's basically the main part of the internal feature. However, along the lesser curvature there's a series of longitudinal rugae which are a lot smoother, and this forms what's called the gastric canal, which fluid flows along from esophagus through to the pylorus when you swallow. And it's often noted that corrosive materials cause damage near the lesser curvature of the stomach because of this gastric canal. The next thing that we need to know is the position of the organ. Now, the first thing that we need to know about the position is the vertebral levels. The stomach's general position is quite variable, but the main things that are fixed are the gastroesophageal junction and the pylorus. The gastroesophageal junction lies just to the left of the midline at about the level of T11 or T10. The pylorus lies to the right of the midline at about the level of L1 or the transpyloric plane. The next thing we need to worry about is the peritoneal relationships of the stomach. The lesser curvature has the whole stomach is an intraperitoneal organ. That's the first thing to consider. It's suspended at its lesser curvature end by the lesser omentum, which attaches it to the L-shaped fissure on the undersurface of the liver. The greater curvature has suspended down from it the double fold of peritoneum known as the greater omentum. The upper part of the greater curvature is connected to the hilum of the spleen by the gastrosplenic ligament, and not shown here, the fundus of the stomach is connected to the diaphragm by the gastrophrenic ligament. The next thing that we need to consider is the stomach bed, which can be constructed by considering the layers of the abdomen, as we talked about before. The posterior surface of the stomach, it must be noted, lies against the lesser sac, which separates it from these structures which form the stomach bed. Firstly, the first layer we have is the muscles, and the muscles that are present in the stomach bed are the crura of the diaphragm. The next thing we have is the big blood vessels of the abdomen, and here we've got the abdominal aorta with the celiac trunk and its branches. The next layer of structures is retroperitoneal viscera. The first of the retroperitoneal viscera is the upper pole of the left kidney with the suprarenal gland, which is located as the arrow points. In front of these structures, we've got the pancreas. mainly the body and tail of the pancreas. All these structures are covered by peritoneum, and below, at the lower border of the pancreas, we've also got a double fold of peritoneum attaching to it, which forms the lower part of the stomach bed, and this is called the transverse mesocolon. The next thing that we need to consider is the position in relation to other viscera. The important thing to note is that the fundus's stomach lies behind the left lobe of the liver and lies in front of this, the spleen. The function of the stomach is basically physical breakdown of food, which is achieved by peristalsis, and also initiation of chemical digestion of mainly proteins. This is achieved by HCl secretion by parietal cells and pepsinogen secretion by chief cells in the gastric glands. The next thing that we need to consider is arterial supply of the stomach. Now, arterial supply of the stomach can be considered as a series of channels along the lesser curvature, a series of channels along the greater curvature, and a series of short gastric vessels to the fundus. Now, the series of vessels along the lesser curvature include the left gastric artery, which is a direct branch of the celiac artery. You've also got the right gastric, and then the arch is completed by the right gastric artery, which is a branch of the common hepatic artery. The arch along the greater curvature is formed by the gastroepiploic vessels. We've got the right gastroepiploic artery, which is a branch of the gastroduodenal artery, which is here, and the gastroduodenal artery itself is a branch of the common hepatic artery. And the arch is completed by the left gastroepiploic artery, which is a branch of the splenic artery at the splenic hilum. And the final thing is you've got the short gastric artery, which once again are formed by branches of the left gastric, which are formed by once again by branches of the splenic artery. The venous drainage is very similar, so you've got a series of channels along the greater and lesser curvatures, and you've got the short gastric veins. The short gastric veins drain into the splenic vein at the hilum of the spleen. They travel via the gastrosplenic ligament. The splenic vein also receives the left gastroepiploic vein, which travels via the greater omentum. The right gastroepiploic vein drains into the superior mesenteric vein at the lower border of the pancreas, as you can see here. The veins along the lesser curvature include the left and right gastric veins, and both of these veins drain into the portal vein at the superior border of the pancreas. The next thing we need to consider is lymphatic drainage. Now, lymphatic drainage, the important thing to remember here is all lymphatics from the stomach eventually drain into the celiac group of preaortic nodes. However, there are three main zones of drainage which divert lymphatics to different areas, to different intermediary nodes before it reaches the celiac nodes. The part of the stomach near the lesser curvature drains mainly into the nodes along the right and left gastric arteries before it drains into the celiac nodes. The part of the stomach along the greater curvature drains mainly into gastroepiploic nodes before it drains into the celiac nodes. Around the pylorus of the stomach, the stomach also drains into pyloric nodes, which lie above and below the pylorus. And finally, the left upper quadrant of the stomach, the lymphatics follow the short gastric vessels to the splenic nodes at the hilum of the spleen before draining into pancreatic nodes along the splenic artery before finally draining into the celiac nodes. The final thing to consider is the nerve supply of the stomach. Now, the nerve supply of the stomach, with any nerve supply, if anyone asks you to describe the nerve supply, you should consider the afferent supply as well as the efferent supply. Now, the afferent supply, the pain mainly follows the sympathetic fibers. So it passes through the celiac plexus and follows greater and lesser splenic nerves to reach the sympathetic trunk, and from here via white rami communicans, it then connects to T6 to T9 segments of the spinal cord. So the pain is mainly felt in the epigastric region, which is innervated by T6 to T9. The efferent supply, with the efferent supply of viscera, you need to consider both parasympathetic and sympathetic. Sympathetic supply is from the celiac plexus, and the celiac plexus sends branches along the main arteries which eventually reach the stomach, which you can see here. The parasympathetic supply is not from the celiac plexus, it's more directly from the anterior and posterior vagal trunks, which I can't really see. That's one branch of the posterior vagal trunk there anyway. It's from the anterior and posterior vagal trunks directly to the stomach. And these vagal trunks can be selectively ligated to in extreme cases of peptic ulcer disease.